Hey guys, welcome to Top Channel 101. So it seems a lot of you are really loving the Learn Houdini, like his Blender series. So let's continue that, and today we're going to be looking at some rigid body simulations and creating fracturing inside Houdini. So in Blender, the way you do that is by use of the popular add-on, so fracture, which is inbuilt. So you just go under add-ons and search for fracture, activate it, and all you have to do is select an object like this. It usually needs to have some subdivisions to create good fractures. Select it, go on object, quick effects, so fracture. I use on vertices, add some noise, and maybe custom collection and interior groups and an interior material, and that's it. You get some fractures. This is all good for something simple, but you lose the procedural nature of things. So for example, if I wanted to use maybe a cylinder, I would have to do the whole steps all over again. It lacks that procedural nature that we all love. And another thing is that when it comes to adding physics, so let's say if I add physics to these objects by going an object, rigid body, add active, playback, it works, but not if say, let me select this mesh and select these vertices here and subdivide. I want to just subdivide them a few times. So if the mesh interlocks like this, you are going to have some issues. See, it starts to explode, jump out like that, and let me add a ground here. So you see that it just explodes up like that, especially if things are intersecting, something that doesn't happen in Houdini. So you can see how that is exploding. You can try and change this to mesh, but that usually increases the time it takes to simulate, and you can see we still don't have that issue fixed. You can reduce the margin. Let's say this is 0.004, and sometimes it will work, sometimes it won't. Like in this case, we're still having that issue or where things are bouncing. But let me show you how something like that can be set up in Houdini without any issues. And another thing I'll show you is how to maybe create, if say this was a rod, how we can make the rod caving in and direct how things are going to cave in. So let's start with adding a cube. I will just use a cube. This is going to be our geometry container. So we have to enter that to start editing that geometry. So I'm going to select the cube, and I can turn on these gizmos so that I can easily edit this mesh. I want it to be a bit longer. Let me make it a bit wider like this, and make this is, and if you want to push it above or on the surface of our grid, we can use a node called match size. And if you take a look at that, you can see it has moved it to the center of our grid, but you can use Y justified to move it to the minimum point so that the base of the geometry is on the grid. The next thing to do is to fracture this, and in Houdini, to fracture objects, all you have to do is use scatter. You have to scatter some points. This is going to determine how many points you have, similar to saw fracture when you are fracturing an object. So under object, quick effects, saw fracture, you have the option to add a source limit, basically the number of points, the number of fractures you have. In Houdini, that is simply controlled by this scatter amount. So let's say we want about 500. Let's do something like this, and then you just connect this to a Voronoi fracture. All it requires is some points and the geometry. The geometry we're going to use is this here. So I'll just connect that and then bring in our points. So let's take a look at that. You can see the fracturing. I can select the scatter while keeping the Voronoi node as the active node, and I can edit the number of points we have. You can see how procedural that is, and we can use the explode view to see the geometry. Now I want some detail inside here. You can use a node called RBD Interior Detail, and if you look at that, explode. Now you can reduce the detail size, and you can see now we have some interior detail. By the way, all this can be handled by just using the RBD fracture material fracture node, and that will just handle everything for you. So if I use the explode view here, it has done the fractures, and if I want interior detail, I can just go under the detail and turn on edge detail, and that will give me similar results to what we have here. But here you just have a little bit more control, and in future tutorials I can even show you how you can further emphasize on the detail by using other nodes. But for now, we scattered some points in the geometry and fractured it, added some internal detail, and this explode view is just to show you how everything looks. For quick preview, I'm just going to use the RBD material fracture. It creates better fractures, and let's add internal detail, and you can see how it's also adjusting, changing the edges. Let's add an explode view. So the purpose of learning Houdini is to do things that Blender struggles with, and one thing Blender struggles with when it comes to fracturing things like this is objects that interlock like this. Blender doesn't handle very well, and if we throw, you can see these here, you can see they're creating interlocks, and I can even go into the detail, adjust the noise height. Let's do 0.3. So you can see that we have that interlocking in here, and if I use an RBD blade solver, playback, you can see nothing explodes, though the detail is intersecting. And I can even, let me just add a ground and a collisions here, ground plane. You can see we don't get that explosive effect. I want to keep things simple, so I'm going to go back to the fracturing. Let's increase the detail size and remove some of the fracturing, increase the particle count, just like that. And another thing that Blender struggles with is controlling your simulation. So for example, instead of using the bullet solver, which is quick and easy to set up, we can create our own solver that gives us more control over the simulation. So we can add custom forces and other things. So I'm going to first get rid of that and maybe get rid of the explode view. I'm going to move this up. I use a transform node, move this up just like that, so that when we simulate it can fall down. Now what Blender struggles with is if you wanted this to propagate, so maybe cracking and these fall while other pieces are not falling, it's very hard to control something like that unless you're using an add-on like RBD Lab. But for Houdini, we can set up our own solver, our own rigid body system using a DOP network. So search for DOP network like that. You don't have to worry too much about what a DOP network is. Think of it as setting up a rigid body system in Blender, and let's say this is our object. We click on the rigid body system, which is essentially creating a DOP network like this. But instead of having all these settings already set up for you, imagine this was entirely empty, and each of these panels was a node, a different node you had to drag into your rigid body setting. That's basically what we're going to be doing with the DOP network. When we enter it, you see it's completely empty and only comes with an output. That way we can set up all the things we need ourselves instead of using something like the bullet solver, which has everything set up for us from gravity, ground, and other things. And in fact, if you enter this by double clicking on it, you will see that actually we need to go back one step. You can see that this is what is used to set up the DOP network, and we can set up something similar, except it's not going to be that complex. It's just going to have a few nodes. So yeah, just consider this network as an empty panel without any of the collision settings or whatever Blender has as default. So when you're working with rigid body systems in Houdini, Houdini prefers you work with packed geometry. Packed geometry is basically simplified geometry that doesn't have a lot of detail. For example, if we use, let's bypass this and use a test dummy. Houdini comes with a lot of test dummies that you can use. So we have a capybara. If I take a look at that, you can see it has textures, it has animation, it has a lot of information that comes with it. That is not necessary for a rigid body simulation. So Houdini simplifies that geometry, and by creating a packed geometry, to make it easy to compute and make it faster for the simulation. And that's what we're going to do. And just to show you how procedural Houdini is, so all of this node tree generated this type of fracturing, but we can switch out this box for our capybara geometry, and look at that. We have all of this set up. Now we are having some issues here with maybe some intersecting pieces that we could fix, but just for demonstration purposes, I'm not going to do that. Let me just use a better geometry. So let's use, there is this rubber toy. I think its geometry is a little bit better for fracturing. So you can see, I can use an explode view. Without doing much, we can switch out the geometry as we want. To use this in the DOP network, we want to pack it so that is simplified geometry. So let's use an assemble node that is going to allow us to pack the geometry. So if I look at that, it's going to simplify everything. And in fact, if I use the test geometry and look at the assemble and use create packed primitives, you can see that it removes a lot of attributes and information about this geometry that is not necessary for simulation. And in fact, if you move your cursor over any node and click on the eye, it will show you all the parameters or attributes as that are attached onto that geometry. So you can see we have positions denoted as P, name, normals, UVs, groups, and other things. But when you pack it and look at that, you can see we only have name and position. We don't have all of the other UVs and other things on that geometry. Now, another thing we're going to need in the DOP network is access to this node tree. Right now, if you go in here, you can see that we don't have any of that geometry because we have to import it in. And Houdini, because it's based on a node tree, you can access data from any level of the tree or any branch. For example, if we bring back the rigid body, the bullet solver, RBD bullet solver, we can run it on this packed geometry. Let me make sure that I have a collision ground. Playback. And you can see that works just fine. But I can also run it at the test geometry directly. And you can see that that also works. So we need a way to tell this DOP network what level do we want to access, whether it's at this level or at this level or at this level. Now you can also just access the node directly by looking up its name, but it's preferred to just use a null object, which is essentially an empty in Blender. So an empty like this doesn't hold a lot of information, but it's quite useful here. So I'm just going to call this fractured object, which should look like that. And here we can call this, you can also access this under a null object, call this original object, just like that. So instead of running wires from here, we can use an object merge that gives us access to any node. So if I connect this here, take a look at the RBD. Let me first remove this. Take a look at this. I can access the object by clicking on this and looking it up in the outliner. So we want the object fractured object. And I can see now if I run the RBD, it still works without running wires. So in Blender, the equivalent would be just using under geometry nodes would be using an object info node and selecting any object. So if we look at that, you can see that we have that object here. Yeah, so the object merge is equivalent to the object info node. You can access the object at any level of the tree. I can access the object, the fractured object, or the test object itself, even by passing this null here. So if I click on this, I can just access the, just access the object, the box one object we had before. And you can see how that looks. We want to use the DOP network to essentially build our own RBD solver. So I'm going to enter that. And the first thing I want to do is import in our object. This time we want to use the packed object which is a simplified geometry. You can access it directly using the assemble node or the fractured object, since it's after the assembled objects. So it's going to be the same geometry. So I can come here and search for packed object, and just under the setting, under SOP path, which is basically the object path, I can just look for that, which is, it was our fractured object, accept. If I take a look at that, we have that. If I connect this into the output and preview the output, playback, nothing happens, because we need a solver, which is basically the engine or the brains of this network to create the rigid body simulation. I'm going to press tab and search for rigid body solver, and it will connect everything. If I play back, nothing seems to happen because we need gravity for this. So I'm going to connect here our gravity node. Now if I play back now, perfect, it goes down, but we don't have a ground for this to collide in. Now this bullet solver, if we go inside it and under the dope network, you can see that everything is done for us. It's basically a template for the bullet solver, and can always come in here and take a look at how things are wired. You can see our ground here is wired into a merge. There are a lot of other things that are added in here, but I only care about the ground plane. It's wired into the merge and the gravity, and then we have a bullet solver. We also should have the RBD packed object, which is somewhere here. Yeah, there are a lot of nodes here doing other things that we don't really care about. We're just trying to recreate the same simulation here without that much complexity. So yeah, we want to add some ground. So a ground plane, just like this. And we saw that it was added into the simulation using the merge. So a merge node like this. So I'll connect this here. And if I hit play, now you can see that the object is going through our ground. And the reason for that is that this merge works in a funny way. The order of how these are merged in matters. So if the objects are going through the ground, just change the order. So just select the merge node and drag the gravity down so that the ground is on the left. Now if I hit play, we get the collisions. Originally we were working with, I wanted to use this box fractured. So if we look at fractured like that, so I'm going to switch that up. It should be switched up here as well. So if I play back, perfect. For now, I can select the ground and turn off display proxy so that I can just see the ground just like that. Now in Blender, when you add a rigid body, each rigid body has a type active and passive. When it's type active, it will be dynamic in that it can be affected by gravity and other forces. But if it's not active, so for the type passive, it will just be in the air. It can still collide with other objects, but itself won't be affected by any forces. That's what we want to do. Now, if we go to the packed object, select that, you'll see that initially the initial object is type active. So by default, whenever you create an object, a rigid body object, let's say let's have a Suzanne head here and give it a rigid body, the type will always be active. And that's what this is doing. All the objects are turned into active objects, but we can create them as static objects. That way, if we hit play, nothing falls. Now in Blender, unfortunately, we can't dynamically change the properties and we can't animate them. So if I hit I can't switch this in the keyframes in the timeline. So it's either going to be active or passive. You can't animate that. The only thing you can animate is dynamic. So if I can animate this, so I can have it as a non-dynamic object and then animate it later to be dynamic, and that will cause it to fall down. But it's really, there is no easy way to control that. So if I wanted anything that this Suzanne head touches to be active, it's really difficult to do unless you're using an add-on like RBD Lab. So let's look at that. So the first thing we want to do is create a way of making a selection of these pieces so that whenever a piece is touched, it becomes active. We want them all to start out passive, and then when they are touched, they all become active. The touched one become active. Now, when we are working in the DOP network, we imported in the packed objects, and they are now being treated as a single object. But we want access over the individual pieces. Let me first turn this back to active so that we can see the individual pieces. Yeah, we want these individual pieces. And the way you do that is by using an SOP solver. This is an operator that works on individual pieces within this network. Don't worry too much about what these things are. The point of these lectures are to just give you an idea of how Houdini works. So you don't have to memorize everything or understand everything right away. You just have to grasp the concept behind how things work. So right now, this whole tree is running the simulation on everything at once, but we want to also deactivate or activate individual pieces depending on whether they're in a certain group or not. So that's why we are creating this SOP solver, which will run on individual objects. So we can connect it here, and you can even see the colors are matching. So just connect it to any of these nodes. If we enter this solver, you can see we have a bunch of inputs, but we only care about this here. And this is, again, is to allow us to select individual elements and make them active. We can't do it here at this level because this runs on the packed geometry as if it was one object. Yet we want to run the solver or activate the different elements as if they were individual objects. So we have an input and an output. And what we want to do is create a selection of different objects. And the way we do that, we can use a group node to basically create a group selection of the elements we want to activate. Now, if we go into that group, we can see that it has selected everything. So let's disable best group to disable everything and use bounding regions. And let's activate the gizmo to see where our bounding region is, and I'm just going to move it up here, and you can see right away that it's selecting pieces that are within that bounding region. Now I can change the bounding region to a sphere, just like that. That way I can animate the size to shrink or grow. I can even animate this. Hold on Alt. Make sure that this is set to 0. Hold on Alt to insert a keyframe and go to frame, let's say 49, and increase the size about there. Hold on Alt and click to insert a keyframe. And now let's first go back to the solver, to our DOP network. Select the packed geometry and change this back to static. Go back to our SOP solver and let's take a look at our animation. So you can see that our selection is increasing. Perfect. Now, this is just creating a selection. Now we have to change the objects within that selection to active. If you go back to the DOP network level, to the DOP network, this is what we are working with. Actually, we can even activate it here. If you move your cursor over it and click on the eye, you can see all the attributes that are on every individual point or primitive. Primitive being the individual pieces. Now you can see we have an attribute called active, and that's what we want to change. If we go in here, this node changes that attribute to whatever we set it here. So we set it to static. So all of these individual pieces are not moving because they're set to static. Now we want to change those pieces to active based on whether they are within this bounding region or not. So to do that, we're going to do some scripting using Vex. It's not that complicated. It's basically how we use drivers in Blender. So for example, let's add a force. Let me first select everything and give them a mass of 0.01. And maybe let me also go in the scene settings and remove gravity. So if I hit play, you can see nothing really happens. Okay, they are moving, but they're not falling down. I can add a force, let's say wind, and I'm going to add a driver that increases this wind strength by time. So I'm going to use hash frame, and you can see that the strength of the wind increases by time, which is basically what we are trying to do as well. It's scripting within Blender. So we're going to do the same thing, scripting within Houdini, but in Houdini it's called Vex. So, and to do that, we're going to do it on every piece that is activated. So we're going to use a node called Attribute Wrangler. And what this does is basically telling Houdini to apply the script we are doing on an attribute. And if you go back, you can see that we had an attribute called active. That's what we want to change. So that's why we're using an attribute wrangler. So we can come back in, go to the SOP, and the attribute we want to change, remember, was active. If we look at this again, it was a type integer and it was named active. So we can go in here and say it should be I at active equals 1 and end semicolon, and that's it. We just want to change the selected objects, and we need to make sure that we tell Houdini or this wrangler node that we only want to apply this to only the selected pieces, and we do that by selecting the group. Actually, we need to, let's rename it here to selected active. That way we can easily tell this node that we want selected active to be our active node, to be activated. That's all we have to do here. Let's make sure we output this. Now we can go in the solver, come back here and play, and look at that. Perfect. So I can even go back in here and go to our group and animate this to come from the left. So I'll take a look at this, go to frame 1 and animate the center to start from there and grow ahead. Maybe it shouldn't be that big, that large. Yes, and maybe we don't animate the size. Let's keep the size the same all the way. So I'll right click and delete channels, play back, and look at that. Now, since this is totally procedural, I can go back to my geometry here and look at the fractures, look at the exploded view. I'm going to reduce the edge detail so that this is faster to simulate. Edge size maybe 2 point. And a primary fracture. Let's increase the scattered points to 200. So we have plenty of points. And now all of that is procedural. We don't even have to go back inside this network, which is actually this here. I can just hit play and take a look at that. It's all procedural in that, remember our rubber toy here? I can fracture that. So bring that here. All the fracturing will happen. Let's look at the exploded view. We have fractured this. The animation might be different because, let's see, because of where the object this is. So let me see if it touches it. I think it does. Let's see. So yeah, still works. So you can see how powerful that is. And it's not that difficult to set up as long as you remember. So you start with a geometry container. You fracture your geometry. Let me use this here. You create your geometry, fracture it the way you want, transform it. This is just to check. Then you pack it And if you want something custom, you have to set up your own DOP network, import your packed object, add an RBD solver, add some gravity, and then a ground, and you have to merge them into the output. And to have more control, you just have to create a SOAP solver, and all that is doing is create a selection of what you want to be activated, and use an attribute wrangler to activate the selected pieces, and that's it. If you want the project files, you can get them as a Patreon. And if you want to use, say you have created a simulation like this that you want, and you want to use it in Blender, some things to note is that this object doesn't have any UVs, and actually you can even verify that by looking at this explode view and looking at using the quick UV shade. You can see that, yes, you have some UVs, but they are not the best UVs. So you might want to set up some UVs. The first one I want to set up is for the object here, for the cube. So you can use a UV auto sim to quickly add some sims for you like that, and then use a UV unwrap, and you can see that is going to be UV unwrap for you. And now after fracturing, say here, we still have those UVs, but we can again use some auto UVs, auto UV sim, but only for the inside group. Now, whenever you use a fracture node like this, it creates a group for the interior vertices, similar to how the self fracture does. It creates an interior vertex group. So this also does that. So this auto UV, we only want to add UVs to the interior vertices. So let's see, so it's likely one of these. So I'm going to use that. And to verify, I can even just come here after the explode and use a blast node, which essentially deletes stuff like a delete node. But I want to just verify what I'm deleting. So this is interior concrete fracture. So it's, let's see. Yeah, so yeah, the inside, that's what we want. This, let me first remove just that. This is the inside that we want. So it's what you should be using on the auto UV. Now I can use an unwrap node, but only, you see, without the group, it's also affecting the outside UVs that we had already done. So I'm going to select the group inside so that only the inside are selected.